Hi, this is Aaron Lewis from Franklin Maths again. This is the normal distribution. This is lesson 3, so this is just finishing off a couple of bits and pieces, and then you feel free to finish the rest of the worksheet, and just watch out for any binomial in any of the questions. After this video, we will look at the inverse normal distribution again using a lot of the calculator. It's quite easy to do if you've got the graphical calculator. With the sort of the class wizards, it is slightly more difficult. But for this, I'll be using the graphical calculator from Casio. Okay, so as mentioned before, all normal distributions can be sort of converted into the standard normal distribution. Then you should be slightly familiar with this one. So if you remember, this is given a z, so the standard normal distribution is given the value as z, again with tilde, so n again takes the normal distribution, and 0 and 1. Okay, so I'm going to be using this distribution again. Notice this time the only thing I've done, and this is a habit of the exam board, is to write 2 squared in there. Not to confuse you, just because whoever wrote the question, that's what they decide they want. So sigma squared is equal to 2 squared. So sigma is equal to 2. I know it's the same distribution as used before. It didn't make any sense to me to keep chopping and changing. Okay, so the sort of questions you're going to get is something like this. So again, same distribution, but if I want to write the following probabilities in terms of z, again, your calculator will give you most of this, but it is always useful to be able to do the formula as well. Okay, so these are the two questions we're going to look at. And then after that, you should be able to get on with question 3 and then move onwards very quickly through there. Okay, so pull this all back up again. So the formula you guys need for this is, it's not too much different from what we've done before, but I'll jot it down. So if we've got the probability that x is less than x, so this in this case here, the lowercase x there is 9.5. Now that's the same as saying the probability that, this time I'm going to be using a z because I'm going to convert it to a z-score, is less than. Now it could be less than or equal, but because this one's a less than, this one's a less than, it doesn't really matter. We're using continuous distribution anyway. Now, if you remember from the last video, in terms of converting it, first of all we sort of undo the translation of the mean, and then we scale by the standard deviation there. Okay. Again, as I said to you before, I think your calculator will do this for you anyway, but it's worth being able to do it. So all we're going to do is write down all the bits and pieces. So I'm just going to put an equals on this. And let's have a look here. So we know what mu is, we know what sigma is, we know what x is, so we're just going to work it through the formula. So this is the same as saying probability of the z value is less than 9.5, subtract mu, which for some reason I've not written what it actually is. I'll just change that quickly. So mu in this case is 10, and we're dividing through by 2. So the probability in terms of z-scores, instead in terms of the standard normal distribution, the standard normal variable, you'll see these sorts of words, but it'll always say about standard normal, or they'll talk about z-scores. So this becomes minus a half divided by 2. So that's minus 0.25. Okay, so this time I've converted into a z-score. So if we check this on the calculator, okay, so here's the calculator. Just going to press exit there. Let's have a look there. So if we're calculating that the probability is less than 9.5, so it's to the left here. So my upper is going to be 9.5. My lower, well, I can choose anything as at least 3 standard deviations away. So just for, well, because I can, I'm going to just choose a really small number there. Or so as far away from the the mean as I can. Check everything else is right. So if I press draw there, and you can see the Z value for my upper is minus 0.25, which is what we expected from doing the math. So use your calculator as much as possible. Just get rid of that a second. Get rid of the calculator use the calculator as much as possible to guide you, but make sure you can do the maths as well. This could be a 1 mark question, it could be a 3 mark question if it's just show that. Okay, right, moving forwards. Okay, similar sort of question. Again, I don't think you need me for this, but we're just going to convert this very, very quickly. So we're going to use the same formula as before. You do need to know this for your exam. We certainly need to know that Z is equal to X minus mu over sigma. So you can convert these into Z values first and then just bung them through the formula, or you can write the whole thing out. It doesn't really matter. For this particular part, I'm just going to convert each one. It doesn't actually matter. So it's going to be 8.5 minus 10 over 2. So this is me working out the Z value for the lower value here. Uh, 8.5 take away 10, so that's minus 1.5 divided by 2 minus 0.75. And for the other one, the upper value, really maybe should just put upper as a sort of subscript here, but it doesn't really matter at this moment in time, not when you're learning something for the first time. So 11 minus 10 over 2. So my Z value for my upper is going to be 1 over 2, which is 0.5. Okay, let's just have a look at the graph here. So what we're saying is, if I've got minus 8.5 here, which is around here, and 11, oh, that was 12, so that's 11. So the probability of this area here, sorry, not the probability of this area, but the area of this, which is the same as the probability, is going to be the same as minus 0.75. And look, it looks almost in the same place, look. And 0.5, in fact, it is exactly in the same place. It's just a different scaling. So those two do match up perfectly. So there's your 0.5 or a half, minus 3/4 there, or minus 0.75. There is my 11 there, and there's my 8.5. So you can see these two are sort of the same. It's just about scaling it with this formula here. Okay, this is quite a neat little skill to do, and being able to convert it into Z values is quite an important skill. It was a bigger skill in the old syllabus on the old S2 module. In fact, you had a table of values for this, but we're armed with a calculator. You should be able to do this. So I'm going to check this on the calculator, make sure I'm right, and then everybody can sort of move forward with the worksheet. Okay, so here's the calculator. Just press exit. Now I just need to change my value. So my upper value this time is going to be 11. And my lower value is going to be 8.5. Go down. I mean, you could press calc, which again, it has given me the values. You know, I can work this out probability wise and just check. Yep, they're the two values I had a moment ago, but I always like to draw it. And there we go. Okay, so being able to convert it to Z values is quite a neat little skill. Make sure you're using your calculator to check. Make sure you can do it properly and then check in your calculator. Or start with your calculator and then make sure you can do it by maths. Either way, the two should tally up. In the exam, I can't be sure in terms of the number of marks for this. Right, so you should be able to move question through onwards. Just watch out for any questions which involve you be able to do more maths. So obviously when you work with the normal distribution, it does give you a probability, but then you might be asked other questions from that. You might be asked to, if something happens 3 times, well then that means you need to cube it. Some of the questions might involve binomial and ask you to compare with the normal. Make sure you can do that. In this video, I'm not going to put any work on the binomial distribution. Just that should be in your notes from previous years, or I will be making videos of that as well. Okay, good luck. Any questions, send me an email. Thank you.